First, thanks to all of the organizers for letting me give a talk. I wanted to give you the slides, first of all, so there's a QR code there. You can get the full resolution from Google Drive in case you want it, but if you come in late later, there'll be the same QR code later. I thought it's fun because, it's a frontier IR talk to give some time to think about what are the actual trends that we might want to see in IR and why we might think they're irrelevant, right? Because, keynotes are supposed to be a little bit polemic, right? They're more fun that way. So you can debate whether you think what I have to say has any useful signal or not. Okay, so I wanted to start by giving you a little bit of flavor about how I induct my postdocs and PhD students. When I started my lab, I found that there are people who want to come to the lab, and gradually over the years, there are just too many of them. We have to set up some entry-level requirements, and one of them that I give is a free-page critical survey task. Okay. Um, and I asked them, what is the future in the specific area that you want to do research on? And why is it so important? Okay. Now, critically, this is not a literature review because we all write literature reviews in our papers, right? That's to justify what we're doing. In many ways, I think of the literature review as a climax in a movie, meaning that you are supposed to set the critical problem, and only when the methodology starts, that is when the resolution of the problem comes about, right? If you think of it from a narrative standpoint, it's very important to get the argumentation right. So that's what I try to do is to ask, prospective students and postdocs, what is the most important area and how do you justify it? Because you are basically arguing for 4 or 5 years of PhD scholarship, right? To say that you need to study this work, it's going to contribute to mankind's importance, right? But the important thing here is that we want to make sure that you can argue well and in a limited space, right? Because if you come to SIGIR and there's 10 pages, it's ACM style, or you come to something like AAAI with 6 pages, it's still a lot longer than what you would get in a free page paper. And as most of us would tell you, writing a short paper is absolutely a lot harder than writing a long paper. And long papers these days are incredibly long, right? Because you have all these like blasted appendices that you can put and hide things in, right? It's almost not a self-contained paper when you think about a normal long paper. Okay, so I like to critique these papers because they're very short, and if I can trim, let's say, 4 or 5 words from each paragraph, that's an extra page in a 10-page paper, right? So that's that much more you can fit in content. Okay. So actually, I don't care what they write about. I care about their argumentation, how tight they can write it. Because the more space you can fish out of a paper, the more entropic, the more signal, the more entropy there is in what they're saying. Okay. So logical argumentation is really important, and you have to use citations to buttress the argument, right? Not to carry the weight. The weight comes from how you argue, but the citations are just to tell people, I know that it's substantiated well. Okay, so I like to think of it in some ways as another talk that I gave yesterday about particle research. Okay, so just pretend for a second, all right? We are in a space, a manifold, if you will. Okay, this manifold is the manifold of research, and we are all particles on this manifold. And we have some acceleration, some velocity. And sometimes, they coalesce. You come with co-authors, and then you make a publication. Bang, you have an observation. Just like the particle collision, right, in a bubble collider, right? So you can think of this as a way of coming up with ideas and how to look at what's happening around us. Okay, so when we think about this, it's important to think, okay, what is the direction that other people are going in? What's their acceleration, right? So when you read a paper and you look at what are the future works that they're doing, because each publication is basically an observation in time, right? But that time is not static because it's 2026 now. What you're reading is archive papers from last month, right? It's already old hat, right? So they've already moved on with that. So how can we decide where we're going with this? Okay, so I gave a very polemic talk title, so I'm going to give you a top five, right? And then I'll tell you why they're relevant. And then, at the end, maybe we'll talk a little bit more about some top five, okay? So the first one we heard this morning, actually, it's about multimodal retrieval, right? There's a lot of work going on right now because we have more and more modalities coming online. We have sensor data coming from Internet of Things. We have video data, right? We have 3D spatial data, okay? And all of these are giving us a lot of compositional semantics, which our vector space models and our embedding systems are not very well trained to deal with, right? That is because they match semantics pretty well, but they don't have any way of really easily expressing constraints, right? We have ways of doing embeddings, but vector differences don't quite express what we mean by semantics of composition or restrictions with respect to time, okay? So we saw this earlier in Aishin's talk if you were here for his talk earlier. How about number four? Okay, so actually this is a set. It's not meant to be like top five. Okay, so don't read it as they're progressively getting better. Okay, how about co-adapted retrieval and generation? We saw this just now with Ray Lin's talk, right? Because here we know that retrieval is part of the process in LLM generation. So there's a lot of processes where we have to go back and ask ourselves, are we doing the right thing when we're dealing with generation of processes afterwards, right? So especially for things like deep research, which we just heard about, right? Agentic frameworks, they're going to be used by agents for humans, right? In deep research. But increasingly, our research landscape, our IR landscape is going to look less and less like humans driving it because humans are now all of a sudden managers, right? We are just managing these huge infrastructure of agents. A little bit thousands of agents going to do a task because we have agents generating instructions, generating research manifolds, generating then verifiers, etc. All of these types of competitions are happening for us. So an open question is there, right? What is the value of having co-adapted retrieval when what's consuming our IR, our generation, are actually other agents, right? Do we actually want to communicate in English? Should we be communicating in OWL or some other type of JSON format? Because that is more token efficient, okay? How about the value of diversity? Because many times when we do search engine optimization, right? Google or other agents will try to show you a diversified set of results to make sure that you've comprehensively covered all aspects of a query, right? But maybe that's not what we want, right? Because if an agent is operating, they have an objective in mind, right? So when we heard the earlier talk about co-adapted retrieval and generation, if we're doing the generation, but it's only part of the process and we want to optimize and downstream process, perhaps that diversity is superfluous. It's not needed, right? Because we just want to drill down. So do we want to actually do all of this extra work to expand, do Colbert and other things to try to align lots of different answers? Maybe, maybe not. Of course, we all know that things like deep research, long-term thinking, and dialogue, they're very hard. In IR, we tend to study small snippets, right? So we have to do rollouts when we're talking about conversation, right? So that requires reinforcement learning with verifiable rewards and other things like this. We saw this also in the last couple of talks, where especially for specialized applications where we don't have enough data, then we need to simulate data, right? So we see this in a lot of talks over AAAI this year, okay, and even last year, where we're using LLMs as a judge to validate whether the data that's created is actually good enough to be silver data or is it bronze data or anything else, and to balance how we're going to use that information to be able to calibrate a performance system downstream. What about two? Right? We see a lot of work also in many areas, not related just to AI, but also in SIGIR, web, also in recommender systems on the RecSys, about the fairness, accountability, transparency, and equity. And we can understand why, right? Because all of these times when we're talking about retrieving results, these results give us evidence, right? They give us the provenance for why a particular generation came out. And again, here we're talking about the diversity for human judges because we want to make sure that what we are using downstream is fit for human consumption, right? And there's a lot of talk about making sure that we have sufficient exposure, relationship, and diversity, and to think again about what I said earlier about when it's being used for a human user and when it's being used for a downstream agent. Okay, another one I think is really, really important. We have one student working on this right now, is being able to think about recommendation as a very, very important process, which we really haven't started to understand adversarially yet. Okay, recommender systems drive almost everything these days. Even archive papers that come to us are not search engine driven, right? You think about all the papers that come to you, all the news feeds that come to you, everything that we use to process and think about our lens to the world, right? And arguably, a lot of that has caused a lot of polarization and other problems that we see, not just in academia and social settings too, right? And it has enormous amount of political and commercial value because governments, corporations can steer this information, right? So this is a very big problem. And we've seen this type of agenda as well as fate from the last slide as being very critical things that we need to worry about. Like if you go back and watch Kate Crawford's NeurIPS keynote around 2020 or so, right? She highlighted the Google search results for CEO in image search, right? What did it show? All males, all whites, right? And Google is not to be faulted with that because that is what the landscape looked like, right? But Kate would ask us, is that the type of picture that we actually want to portray to society when people search? Do we want to see a more representative lot? Okay. But that's not actually what the data shows. The data shows at that time, CEOs were mostly white male. Okay. So if we want to insert diversification, we want to insert exposure, we are actually in recommendation systems doing political work. Okay. As Kate Crawford says, we cannot just say we are doing the math, we are doing the optimization. We, as algorithm designers, are making a choice about the world that we want to see. Okay. And that means robust recommendation of sequential recommendations, which are more and more engaged now that we have LLMs doing recommendation, are extremely important. So I'm going to allude back to that manifold that I told you about, where we have particles running around, right? So when we have particles running around, all of us are scholars, right? We want to publish work, we want to make our impact on the world. So we can think about this manifold, okay, where particles are existing as a space, right? It has bumps, it has curves, and there are certain things that are easier and harder to do depending on what you're doing. For example, we can say that, okay, as a particle, a researcher, I have a certain amount of bandwidth daily to decide what I want to do. So I have a beam of different activities that I can do. Okay. And I can search the space. I'm a dot on this space and I have to figure out what's useful to do. Okay. But when we do certain types of activities, for example, we make data sets available or we make GitHub available, okay? We are incentivizing, just like Trek did many years ago, for those of you us who know Trek or SIG, that where we have a SIGSEM, where we have SEM-eval, right? All of these cases where we make it easy for us to do certain tasks. And many times I'll tell my students, actually, why don't you create some task like that so that you can get more eyeballs on your work and gain more community support, right? But this also creates a variance in the space, right? We are incentivizing certain types of research and making it harder to pay attention to others. Okay? But the problem here is, unlike LLMs who are doing deep research for us, we as human scholars, we can't restart around this vector space, right? We start in an area, we specialize it, and we have a limited capacity to move around in that space, right? So it ends up that we are catalyzing certain areas of work using fast research methodologies, but it may make it harder to reach other spaces because there aren't data sets, there aren't other things that make it easy to do impactful research that's not so short term. And this is especially important in today's age because we have all of these other types of methodologies that make it easy. So over here, you can see the arrow that indicates when research is published. And this is a slide that I borrowed from Altmetrics. You may know them. They take a look at other types of metrics besides just citation data, right? And they see here that there's a lot of the other things that happen before publication. So for example, archiving or patents, and then maybe very later on, you'll see policy, which is the bottom line here, being enacted and being used to create new ideas and catalyze research and funding. Okay, so because of all of these accelerations, can have some problems in incentivizing certain areas of research, right? Having archive, having a GitHub, having shared tasks makes it easy to do certain types of research, but not others, right? And in many ways, we are set up to optimize against this. This is sort of like the reinforcement learning that's happening in the real world, right? Because we metric it using bibliometrics, and we can tune for that. We can say, oh, this area is not getting enough citations. I'm going to abandon this area. I'm going to go into another area as well. Okay, so for example, in this slide, there are two researchers. Okay, you may not see the other one, but the person there is actually the research assistant. This is an automated laboratory. Okay, so the scientist is actually the box. Okay, the assistant is just there to refill the reagents, right? So it's actually doing research on its own. It's being able to do all of the research in a closed loop very quickly, just like some of the research agents that we are creating these days. So when we have things like large language models and we use large language models to consult, okay, then we are getting things like regression to the mean because we can understand that large language models are just an amalgam of our human knowledge, right? So because of that, when we consult large language models, we are also gravitating towards certain outcomes that are standardized, right? Being pushed by the entire community as a whole. Unless we have clever prompting to elicit certain parts of understanding that might be important for the IR community or sub-community. Okay, so that list that I showed you just now, it's fake. Okay, because this was compiled by me over the last 24 hours by using all of our LLMs, right? Because they can do this very easily, right? They can say, okay, let's go through all of the 2025 values in SIG-IR, in ECR, core venues in IR, but also tangential venues like Wisdom, Web Conference, CIKM, KDD, more database-driven things, and maybe other things from natural language. Like my core area is also NLP, so ACL, EMNLP, right? So after I said that, then I asked the research agent, can you sort these by topic? Come up with a list of venues, topic areas for me. So it came up with, of course, the standard ones: retrieval, recommendation systems, evaluations, data scalability, and etc. Right? And then if you look at our own Frontier IR call by the organizers, they also mentioned these things. I don't know whether they used an LLM to write it or whether they came up with it themselves, but there are certain paradigms that they've included, right? So they said, we want to incentivize people who are looking at challenges, models, data training methods, RAG paradigms, and broader frontiers, okay? So all of this I used as input to structure those 5 that you saw earlier, okay? So actually, if you think about it, those things that I presented earlier, you may agree that there's not a lot of entropy there. These are sort of common things that you would expect IR venue to ask you to go and to find the next frontier about. Okay, so in some ways, what I told you earlier was not very relevant. So I'm going to try to do another time with it, okay? And then you can see whether you think these, which are based on more human decision making, whether they're more entropic or not, okay? I don't say that they are, but hopefully we get some idea behind that. And the process for coming up with these other ones are based on having a much wider context. So nowadays, RAG models are all about long context, right? Long context, getting the idea that you can put more tokens, pack them in, but if we can't do that, maybe we can summarize and poke them in a shorter context. But wide context looks at a wider field of vision. Okay, so instead of looking just at the top areas, which are just, IR related, we want to look at larger contexts, okay, such as, other fields and disciplines or society as a whole, okay? So this goes back to the Humboldtian model of the university, okay? Maybe the idea of a university system, okay, in the German methodology, was to put lots of disciplines together in one place, okay? The reason for that is so that they can butt heads with each other and come to solve what we now call wicked problems, right? Climate change, overpopulation, xenophobia, all of these things that require understanding from several different viewpoints to come up with a solution, okay? So in this sense, you can think of it as an instance of slow science as opposed to fast science, okay? So when I talked about earlier about archive and GitHub and everything like that, those are things that incentivize quick turnarounds, quick publication, but being able to do things and talk to each other is hard work. Interdisciplinary is difficult, right? So that's slow. So when we think about this, right, and we think about fast science, we can go from where we are now and try to roll out, as I told you on the last slide. Okay, so this is our standard A-star search where we're going from the current place and we're trying to roll out forward, right? Do a simulation forward, right? But we can also do it from a goal-directed state, right? So when we think about artificial intelligence, they also say that you can start from the end state, I want checkmate, right? And I want to walk backwards from that goal state and try to find out a solution. And we can meet halfway in the middle. We can have some type of bi-directional search to find interesting waypoints around this that can lead us to the desired state in the end, right? So when we think about future IR problems, I'd like to just encourage you to think about IR, not 1 or 2 years down the road, but 5 years or 10 years down the road. What does this discipline look like? Is it solved? What other things need to be done in the face of the progression of IR? Okay, so I also do this with my PhD students. When they come in and they do this critical survey, I ask them, okay, imagine you are 4 years later down the road. You have finished your PhD. You are the most hot, sought after property as an assistant professor. Okay, what did you do? Tell me, how did you become so famous, right? What problem did you know that in 2026 you needed to solve so that in 2030, when you graduated, you would be the #1 sought after assistant prof postdoc, right? And so that is what leapfrogging means. When I showed you that particle slide, right? The idea is that you have to know SIEEE 2026, 2027, what's going to be produced, right? So that you can jump forward from there. You can say, I know there will be a data set introduced in 2027 to solve problem X, right? Deep research or whatever, because that's currently what's needed. But when that data set is there, when we've already done all the data augmentation, when we tune those models, what is the result of that work that comes after that? Okay? So we have to do this sort of time series prediction. And as everyone knows, if we could do the time series prediction well, we would have made a fortune on the stock market, right? So I can't tell you what actually the future actually holds, but it is something we should practice because doing this is a muscle. If we practice doing future vision research, you will get better at it and you will be able to find signal where there is none. So here are my five, again, in no particular order, okay? So we know quantum computing is on the horizon. It's making great headway. Do we have IR algorithms to really take in that information into account, right? We have Grover's algorithm that promises that sublinear search, right? So you don't have to scan documents linearly. You don't have to take O(n) time. You can take square root of n time to find answers to this. Okay, so we need new calculus of representation of both queries. I mean, how do we represent both a document and a query in quantum terms? Okay, what about blockchain? Okay, everyone's talking about blockchain, right? But why is it important? Because with RAG, with LLMs on the horizon, right? Well, not on the horizon, already here, right? They can generate documents on the fly. They can actually populate information sources and pollute them. Then, how do we know that something is substantially created by a human being? How do we know its veracity, right? So being able to compute the veracity and its coverage is important because just like media reports do. They take snippets, they take summaries of our works, right? And sometimes not purposely, they miscommunicate what we mean when we're communicating our science, okay? So being able to know what caveats there are to output are very important, okay? So that means the mean and variations in their claims and being able to really understand what could be transmitted and what might be omitted. So actually a lot of information that we get is only partially observable because the LLM or another agent has already digested that us for us, and we may not actually have all of the information visible. What about reconciling embeddings, right? So we have all of this structure. I was talking with Aishin over the break, okay? People are using embeddings everywhere, right? But we have structured knowledge bases, right? So how do we pull these two things together, right? We have dense embeddings that in some ways we can solve. NLP is already somewhat solved, right? In the sense where we don't need context and pragmatic understanding to really understand what people are saying, right? Then, of course, we know in IR, we are doing a lot of generative work where we're using multi-vector representations to find more diverse information. But maybe we want not just multi-vector, right? Maybe we want a distributional idea, having a point cloud of information and being able to calculate on that, right? So especially for queries, but also to know how these change with time, meaning over changes of queries, right? So when we ask an LLM to do something, it does it, but we say, no, you don't quite have it right. I want you to change something, but the instruction following for repeated turns doesn't work very well. How about this? Okay, I went to Schloss Dachstuhl, which is a symposium in Germany on different areas. It was on open data infrastructure, things like DBLP, things like Semantic Scholar. And guess what? They're dying because of what? Access. Coming from where? Agents. Agents are basically pummeling the ACL anthology, the ACM digital library because of all of their requests. Because now a user asking a query is actually spawning somewhere around 50, 60 queries to all of these data sources. They can't handle that amount of access. Okay? And if you just roll this out, okay, eventually it becomes 99% of the accesses are going to be by agents. Only 1% is actually executed by an executive agent that's scaffolding or by a human. Okay? And what's going to happen? How are we going to have the infrastructure support all of that? Okay? Because the cost of substantiating an agent is incredibly low. It's almost zero now, right? So then how are we going to be able to come up with the right protocols to allow quality of service to be happening, right? And it's not so simple because, you have private data, you have public data. You might be willing to share your LinkedIn contact with me, but maybe you don't want to share it with an agent or an agent's agent or an agent's agent's agents. What about my healthcare information? I don't mind transmitting it to my primary doctor, but if he's sharing that to an LLM who's then sharing it to some other data stream, then that's not necessarily a good thing, right? So what does 1 or 2 degrees of access difference and degrees of separation actually mean when we think about IR in the future? Okay, so I think Sia introduced me as a vice dean for undergraduates here at NUS. We have a very large pool of students that we're educating, and we are now participating in one of the largest natural experiments regarding AI. I think some of us may have read the preprint that came out from MIT on 31st of December, right? It basically said that, given an essay prompt, you know, they had students go through 4 rounds of writing essays, either using an LLM, using a search engine, or using their own brain. Okay. And surprise, surprise, on the fourth final session, they switched it around. Those who were using an LLM were now forced to use their brain to do the work. And those who were forced to use their brain were allowed to use an LLM. Okay, so what did they find? I'll leave you the punchline. Okay, but the bottom part of this is that while we are now using LLMs for a lot of different things and AIs for a lot of different things, we are developing possibly, okay, not verified at all, it's not peer reviewed, cognitive depth, right? This means that we are outsourcing a lot of what we do to agents, and we could be, inadvertently atrophying our muscles of cognition, right? And that is very damaging if you think about it. If we think, okay, that our ultimate goal is to have fast, unfettered access to information whenever we want it, and that we're going to write off information retrieval as a research field, just like we did with computation, with human computers in the 1960s. We no longer need people to actually use the slide rule to do things, okay? Maybe that will be okay. But if we think that actually information literacy is a core part of our being, we need to discern what's true and what's not, then we have to make sure that we bring people along for the ride. Okay, so this is a picture of a centaur, right? It was created by Nano Banana yesterday. Okay, but centaurs represent teams of individuals and AI agents. This is the term that was given in chess, right? And in chess, we've seen that human computer teams actually no longer, as of 2026, can outstrip computers by themselves, okay? So that's a very difficult thing to say. We need to make sure that we bring human skills along for the ride because we think that information access, quality assessment are key activities that people need to do. Okay, so actually, that is the end of my talk. I would just say that we are looking for postdocs and doctoral students. So if you're interested in that, please join, scan the deck of slides and go to the last slide to pick up the QR code there. Okay, yeah, so I haven't finished the conclusions, and that is obviously a call for all of us to do it together. Okay, thank you very much.
Thanks for the inspiring speaker from the Professor Mian. I guess you have now new questions or you might have some answers in your mind. Please feel free to raise your hand. Maybe I will kickstart the question. I like the sentence you mentioned. Now the user of this information retrieval are not human anymore. They will be LN, something artificial, and how the communication between information retrieval tools and generation will be designed might be totally different from how human communicate. For example, there are recent popular idea for latent communication. How do you see this field will evolve in the recent future, maybe?
Yeah, I think that's a very good point. I think we need better structures for blackboards, right? Ways that agents can communicate with each other. There are lots of cases where agents can start to negotiate how they talk with each other. Mostly it's popularized by standards that are already there and have a lot of data in public places, right? So writing pseudocode in JSON or in pandas data frames, that seems to work better because there's a surfeit of data out there to do that. Exactly how they're understood, I think we'll see the same type of difficulties that humans have, where one agent and another agent have a different implicit definition of a term that's being used in a JSON form. Right. So I can say disease, but and have it be an attribute value, but that disease in my coding might mean something in UMLS, and in another system, another agent might have SNOMED or something like that, right? So that misalignment is difficult to navigate even for humans, and I don't expect that to be any different from machine agents.
Thanks for the explanation. Yeah, please.
I just had a question. You mentioned how, like, nowadays, there's scaffolding agents upon agents, and agents are cheap. So people are doing anything anymore rather than acting as managers, if at all, right? So my question is this. Um, when things are cheap, we take shortcuts, and I guess society is adapting to that. How do we show that there's going to be a cost for all this? Especially what you mentioned at the end, like the cost for what we are doing right now could be cognition death, like the ability, like human capability is diminishing, right? So how do we ensure that people, like the general society, understands that there is a cost of AI, or agents, whatever we call it, and we need to collaboratively move human understanding along, as well as using AI.
That's a great question. I think it's something that I hope many of us in our room will aspire to try to solve. I have a couple nascent ideas on this, which is that, actually doing awareness is part of what we want to do, right? So ethics and other areas where they're not profit oriented tend to fall on the waysides, right? But actively seeing these as areas for development and making it sort of a corporate social responsibility can be one of the ways that we can incentivize it. That's certainly not the only way. I think a lot of parents, we decide not to give our children the phones, right? Even though they demand it, right? We say there's going to be an implication on whether you can concentrate or not, right? So as we see this rollout, this again, unfortunate or not, natural experiment of AI going, we are going to see implications of that, right? And if we see that our executive functions as adults are not impaired, maybe that's okay. But we are quite worried about the next generation. Like I said, I'm a vice dean of undergraduate studies. I worry about all of the new incoming software engineers. I'm worrying about all the graduate students that are outsourcing all of their paper reviews, their literature surveys to agents to try to understand things because they've gotten just, the summary content, right? Because it's hard work coming up with all of it. I mean, the superficial understanding might be there, but when you drill down, you lack that substance. Okay, I think what will come out of this is that people who've done the hard work, not to just outsource blindly, will be the ones who can use AI more effectively. So in the end, it's those people who will benefit from AI and not be shortchanged by it. But how to encourage that? That's really difficult, right? I mean, I am a father to a teenager, and many of us have gone through these years. It's always hard to listen to parents to say, you should eat your vegetables, you should sit up straight, right? This is a hard sell for many of us. So again, as grad students or beginning scholars, it's also hard to see where exactly is the right line to use deep research and when not to, right? When to trust your own human intuition, to try to put in that cognitive flexing, as I say, to try to build out that muscle that so you can do things on your own. Because otherwise, you're commoditizing your output, right? You're going to do the same as everyone else that can do it through an LLM, right? So then your insight will be worthless, right? Thanks for your really nice question.
Thank you. Is there any questions? If not, we will wrap up this morning session. Thanks again for the sharing from the speaker.
Thank you very much, everyone.